Introduction. Most reasonably literate laymen tend to accept what scientists preach. We are led to believe that there is clear evidence showing that we are made of stardust, that black holes are portals to new universes, and Earth is orbiting the Sun. They must have done some test, measured some missing mass, or observed Earth's orbit to know these things. Right? Actually, surprisingly, that is not the case. 74% of Americans, 66% of Europeans, and 59% of Australians believe that the Earth orbits the Sun. Of these believers, hardly a soul can explain why they believe it, other than science says so, does it not? That person may recall that Galileo had proved the Church to be wrong, and therefore the Earth is now orbiting the Sun. It was Galileo, right? I read a few books by Stephen Hawking, including A Brief History of Time and The Theory of Everything. I found these books to be quite repetitive, and the most interesting repetition is a disclaimer in which he made a remarkable confession. I'm playing a soundbite from his audiobook, A Brief History of Time.
Now, at first sight, all this evidence that the universe looks the same whichever direction we look in might seem to suggest there is something special about our place in the universe. In particular, it might seem that if we observe all other galaxies to be moving away from us, then we must be at the center of the universe. There is, however, an alternate explanation. The universe might look the same in every direction as seen from any other galaxy, too. We have no scientific evidence for or against this assumption. We believe it only on grounds of modesty. It would be most remarkable if the universe looked the same in every direction around us, but not around other points in the universe.
End of quote. Between Copernicus and Galileo, Earth had been removed from the center of the universe. Now Hawkins tells us there is no evidence for it. We believe it because of modesty. This is like standing on Table Mountain and concluding, now all this evidence that we have reached the southern point of Africa might seem to suggest there is something special about the location of Table Mountain. There is, however, an alternate explanation. The view from any other mountain may also appear to have reached the southern point of Africa. It would be most remarkable if Africa seemed to end when observed from Table Mountain, but it does not seem to end when observed from Kilimanjaro. We will soon learn that this logic is a fundamental principle of Einstein's theories, but the primary difference between these two absurdities is that the one can be tested. In fact, Africa does not end at Kilimanjaro, but fortunately for the modesty of Stephen Hawking, we cannot go to another galaxy to verify their assumption. All we can do is to believe it. In fact, we have to believe it because the scientific revolution is based on the assumption that Earth is not at any special location, least of all not at the center of the universe. I will attempt to help you discover why science expects us to believe their fancy theories about frames of reference, relative time and clocks and twins and wormholes that we thought had something to do with science. Aristotle is quoted to have said, "A tiny error in the beginning grows 1,000-fold by the end." By believing one thing without scientific evidence, on the grounds of modesty, while the obvious truth is staring you in the face, may not seem like much of an error in the beginning, but when your modesty requires you to believe one absurdity after the other, one should realize it is time to check your assumptions. Of course, you can believe what you want, but you will soon be deprived of the deception that you were compelled by evidence. Chapter 1. Our Place in the Universe. The currently accepted view among almost all scientists is that we inhabit a second-class planet called Earth, which moves around a second-class star called the Sun, which circles around a second-class galaxy called the Milky Way, which is lost in the vastness of space like a grain of sand in the Sahara Desert. This is called the mediocrity principle. It depicts man's view of ourselves and our place in the universe. Carl Sagan taught we live on an insignificant planet of a humdrum star lost in a galaxy, tucked away in some forgotten corner of the universe. Paul Sartre contributes, even if there was a God, he would not find us. By contrast, God revealed the teleology of creation very comprehensibly. He hath chosen us in him before the foundation of the world. Ephesians 1:4. To support people, he made the earth. Genesis 1:1. To support earth, he made the heavens. To populate the heavens, he made stars. To support life on earth, he made the greater light to rule the day. To fascinate Adam, he made Eve. To make sure he can easily find earth, he placed it at the center of the universe. It seems unlikely to start with such a sensible model and then to end in the chaos of postmodern science. But we managed. In the Garden of Eden, Eve met a friend who claimed to be a nutritional expert with much advice on alternate dietary options. This included fruit from the tree in the middle of the garden. Ever since the outcome of this guidance, man has tended to follow a basic philosophy. Listen clearly to what the Creator say and do the opposite. The claims of Scripture appear self-evident, confirmed by observation and senses. So the ancients knew the earth to be stationary at the center of the universe, and everything else seemed to be circling around it. That idea came from observing and believing what their own eyes and senses told them to be true. The earth was obviously not moving, whereas everything else obviously was. There is nothing unscientific about this view. To be unscientific is to have better evidence and ignore it. We would have to wait a few thousand years before arriving at that strategy. In contrast with Judaic scripture, the Greeks revered a pantheon of gods competing for position and ranking among themselves and in the minds of men. The Olympian gods were the principal deities of ancient Greece, but the sun god Helios was not among them. To men like Pythagoras, this was an obvious mistake. How can gods like Demeter and Aphrodite bring fruit and fruitfulness without the light from Helios? Clearly, Helios was the most magnificent of all the gods and should be at the center of the universe. Contrary to modern perception, the center of the universe is a very special place. To Pythagoras, it had spiritual significance. Newton believed it to be wherever the center of gravity is. Hawkins believed it is everywhere. All would agree, though, if there is a center of the universe, it would be stationary, and its absolute velocity through space would be zero. Imagine two bugs on a water wheel. One sits by the hub at the center, one sits on the rim. After one revolution, the center bug has had no displacement, while the bug at the rim has moved around the wheel. Both bugs believe themselves to be at rest, but if either of these bugs had a way of measuring absolute rest or motion, the one who gets a zero reading will accurately conclude that it is at the center of the water wheel. In the same way, the center of the universe cannot be in motion. It cannot orbit anything, just like the hub of a water wheel cannot orbit the rim. To Einstein, this concept posed a serious obstacle, and he would sarcastically call it a preferred frame of reference, implying that everything was relative and there is no point of absolute rest. Unburdened by excessive imagination, most lay people know from living in reality that everything has a center. The city has a center, the shopping center has a center, the dinner table has a center. In fact, if we tried, we cannot imagine anything without a center. So why would the universe not have a center? To be without a center is to be infinite. Can someone explain infinity? Keep listening. He will soon explain the Trinity and what women want. Like the bug on the water wheel, Pythagoras lacked a means of measuring absolute rest. To be sure, he saw no need for it, as he knew Earth had to be in motion in order to orbit the Sun. Measuring the rate of Earth's movement, v, was of some interest, but it would require measuring the speed of light. This would be achieved by Albert Michelson in 1879. Pythagoras was born 2,450 years before that. But like most people, his lack of data did not prevent him from making conclusions. To his credit, he did not pretend to have measured or observed the Sun at the center. His reasoning was philosophical, believing as he did that the Sun was the most magnificent of all the gods. It is not unreasonable that it should occupy the central position of the cosmos. Johannes Kepler would confess the same in his book Astronomia Nova, meaning New Astronomy, published in 1609. In truth, there was nothing new about the heliocentric model of the universe. He should have titled it Astronomia Antiqua, as it originated with Pythagoras 2,200 years earlier. Chapter 2. Philosophia Naturalis, or natural law. Aristotle lived 384 to 322 BC, 180 years after Pythagoras, but was less interested in the invisible gods than the visible universe. From Aristotle to Thomas Aquinas, the concept of natural law became thoroughly established. They called it natural philosophy. Thomas Jefferson stated it best: "We hold these truths to be self-evident." Natural law finds expression in the golden rule and the principle of reciprocity. People would say things like, "I gave you half of my sandwich, you should give me half of your apple." This law is written nowhere, and yet nobody disputes it. It also applies in nature. When apes are shown magic tricks of objects going missing and appearing, they react with incredulity. It's unlikely any of them have a PhD, but they do know the missing mass theory is absurd. If a rock rolls down a mountain, the people below, noticing the rock, will move out of the way. Their reaction requires no divine revelation or scientist to tell them to move. The danger is apparent. If someone fails to warn her blind neighbor, she would be derided or accused of manslaughter. Claiming she viewed the risk from the falling rock's frame of reference will not gain her much sympathy. Exchanging an obvious truth for a fanciful theory contradicts common sense and Occam's razor. It is not allowed in the practice of law. No jury would accept it, and yet, when it comes to science, we are content to believe the most absurd. This may be because the subject matter has left the realm of common sense so long ago, it has nothing to do with our everyday experience. Very few of us would point out how ridiculous it all seems, for to criticize something implies that one has an understanding of the subject. We will soon learn why the landscape of theoretical science is littered with laws and principles. When something cannot be explained, it is elevated into principle. When something cannot be challenged, it is elevated into law. These laws and principles are not to be understood, they are to be believed. What we will do instead is to discover why science requires us to believe what does not seem to be self-evident. When a theorem is internally conflicted, evidently false, or experimentally proven wrong, but essential to support a favorite philosophy, science has no choice than to reincarnate it into a principle or a law. This strategy was first employed by the Catholic Church and has been perfected by secular science. Chapter 3. Aristotle's Fifth Element. Aristotle found no convincing reason for Pythagoras' idea of Earth moving around the Sun every year. Aristotle's was a theory of relativity. As Earth seemed to be stationary, it follows that the Sun and stars circles relative to where Earth is at the center of the universe. Perhaps the most amazing proposition he made was the evident need for a fifth element he called the luminiferous ether, or just ether. Scientists over the centuries imagined various contraptions to keep and navigate the heavenly bodies in their courses. Aristotle invented the ether. Newton invented an infinite universe. Einstein invented a cosmological constant. What an irony that thousands of years later, in 1887, Michelson and Morley would measure Earth's velocity through the ether. In 1913, Sagnac would experimentally verify the properties of the ether. In 1925, Michelson and Gale would build a vacuum tunnel to verify the presence of the ether inside the vacuum. It does make one wonder how Einstein, in 1905, discovered that there is no ether. This can be better understood when asking the right question. Why did Einstein declare that there is no ether? Being the self-appointed guardian of the scientific revolution, Einstein reasoned that since physical experimentation consistently demonstrated Earth to be stationary, while he personally knew Earth to be in orbit, the simplest solution would be to eliminate the common denominator from all the physical experiments. He therefore declared that there is no ether. By eliminating the ether in a thought experiment, Einstein restored Earth to its orbit and the Sun to the center of the solar system, exactly where he preferred God to be, 150 million kilometers away. By eliminating the ether in a thought experiment, Einstein restored Earth to its orbit and the Sun to the center of the solar system, exactly where God should be, 150 million kilometers away from Einstein. Of course, not everybody knelt at Einstein's altar. Experimental scientists prefer testing over imagination, even Einstein's imagination. But the greater irony is the contradiction between Einstein's own theories of special and general relativity. Having abolished the ether in special relativity in 1905, he had to reinvent it 10 years later. To his credit, he called it different names, such as the fabric of space-time, or quantum fields, or the Sagnac effect. It is essential to be multilingual before doing science. Obfuscation require linguistic prowess. Though Aristotle was not exact in his description of the ether, he understood the need for its function. He knew there has to be something that guides the stars in their courses. Genesis 1 verse 1 states, "In the beginning, God created the heavens and the earth." It seems to imply that the earth is separate from the heavens. Earth is not a heavenly body, just as the heavens are not part of Earth. When trapped inside a vacuum pipe, the ether remains in sync with its universal self. It cannot be contained. It appears to be immaterial, yet interacts measurably with light. It is never in sync with Earth, but like the stars, it rotates around Earth at 15 degrees per hour. Even inside a vacuum, inside a looped pipe on Earth, its consistency allows ring laser gyroscopes to navigate on Earth as they do in heaven, or shall we say on the moon. Aristotle's understanding of the need for a fifth element was visionary. Of course, he left out the other 87 elements, but the ether is an important one, an omnipresent ether that supports light and provides true direction. It almost reminds one of a man born in Bethlehem, of whom it is said, "He is omnipresent, He is light, He is the way and provides true direction." Chapter 4. Ptolemy's Almagest. Around AD 150, Ptolemy used historic and current observations to construct a model of the universe that was prevalent in the minds of kings and laymen alike. The model was able to predict the future positions of stars, planets, and eclipses. Unlike the philosophy of Pythagoras, Ptolemy's model was based on observation, as written down in the Great Treatise, later named the Almagest by Arabic scholars to mean the greatest. He was impressed by the majesty of the heavens and its attendance in providing days and nights, lights and beauty, times and seasons. He thought Earth to be the ideal frame of reference for studying the heavens, especially since he lived on Earth. He thus made virtue of necessity and recorded his observations from Earth. Though Ptolemy's geocentric theory of relativity made perfect sense, like Pythagoras, he could not measure C. To be sure, he saw no need for it, as he was a proponent of natural law. René Descartes reasoned he has to exist because he is thinking. Ptolemy figured, as he knew himself to be stationary, it stands to reason the earth below his feet has to be stationary also. If Descartes stated, "I think, therefore I must be dead," we would not have quoted him to impress our friends. Perhaps somebody did write a thesis like that, and indeed we have never heard of him. Nor will quoting him impress anybody. If Ptolemy concluded, without any measurement or convincing evidence, that he is hurtling around the sun at 107,000 kilometers per hour, his model would not have become the de facto view of the universe for 1,500 years. Perhaps somebody did believe that, and indeed we have never heard of him. Believing Earth to be stationary, as it appears to be, is as rational as believing one exists. There is no burden of proof on a self-evident truth. To conclude the opposite requires compelling evidence. Ptolemy's model was, and some say it is, as observed from Earth, the simplest model. It remained popular with most educated people right until the 16th century. One reason was that most of the educated people of the world, and in particular scientists, were in Europe, which at the time was nominally Christian. Christians have always noted the harmony between Ptolemy's model and Scripture. Chapter 5. Copernicus and the Renaissance. The fall of Constantinople in 1453, at the end of the Byzantine Empire, led to a migration of scholars to Western Europe, bringing with them many ancient Greek and Roman manuscripts. A rebirth of interest in the culture of ancient Greece resulted and took hold of the philosophers of Europe. Copernicus was born in Poland 20 years later, and Martin Luther was born in Germany 10 years after that. Copernicus was fascinated by Pythagoras and Pythagoreanism, which have many useful elements, but it also teaches reincarnation. Luther was fascinated by Jesus Christ and Scripture. He thought everybody should be able to read it. These two men were both earning their living from the Catholic Church. Luther was a priest and Copernicus was an administrator. They would both contribute greatly to the Renaissance by springing two different revolutions, the scientific revolution and the reformation of Christianity. Luther challenged the Catholic Church in ending Bible censorship by translating the Bible into German. Copernicus challenged the Catholic Church in a more subtle manner, due to his own faith having been challenged by Pythagoreanism. His new faith taught a different worldview, with the sun being the most magnificent of all the gods at the center of the universe, and a different view of salvation called metempsychosis, which is reincarnation. Copernicus was 44 years old when he heard of the 95 propositions nailed to the doors of the Catholic Church by Martin Luther, who 3 years later published Freedom of the Christian. Both Copernicus and Luther suffered the man-made commandments of the Church against them getting married. Both were happy to discover from Scripture there is no such prohibition in the Bible. Luther married Katharina von Bora, but Copernicus's rebellion was more subtle. He employed Anna Schilling as his very personal housekeeper. Luther announced his renunciation of Catholic dogma in a speech confessing, "Here I stand, I can do no other," sparking off the Reformation. Copernicus had a more indirect announcement confessing, "Here I lay, I can do no other," for he was dead. Fearing retribution from the church, he arranged the publication of his work post-mortem. In his writing on the revolutions of the celestial spheres, he constructed a different model of the universe based on Pythagoras' view of the primacy of the sun and his own theory of relative movements. He offered no criticism of Ptolemy's model, yet chose to elevate Helios over all the other gods and placed him where he belongs, at the center of the universe. The heliocentric model was less accurate in predicting planetary positions or eclipses, but he got the main thing to be the main thing. The sun was at the center. The implication was, if the sun is stationary, then Earth has to be moving. An essential property of a good theory is that it has to be testable and falsifiable. Demonstrating that Earth is in motion would be the holy grail of scientific revolution. But if Earth is stationary, it cannot orbit anything. Then the sun has to be in orbit around the Earth, which would be the end of the theory. In fact, it should be the end of the revolution. But Copernicus did not propose a method of testing Earth's motion. This testing had to wait 344 years before anyone would devise a method of verifying the model of Copernicus. This impasse and the teachings of Galileo, who was equally unable to determine C or V, gave the heliocentric theory ample time to become established in the minds of men. The change in paradigm from a geocentric to a heliocentric universe became known as the scientific revolution, before a single experiment confirmed its validity. Clearly, not everyone placed equal store by natural law, and the public was taught to ignore their senses in favor of taking a round trip of 470 million kilometers around the sun every year. Our willingness to make the trip is based on its costing nothing. But, as we will soon discover, there is an intangible cost to believing oneself not to be where you are. As Luther challenged the Catholic views on salvation, Copernicus challenged the Catholic views on astronomy. There is much irony in the Catholics never conceding to Martin Luther, who had evidence for his theory, but they did eventually concede to Copernicus without evidence. The bigger irony is that they used to be right on astronomy and wrong on theology. In the end, they are now wrong on both, as Pope John Paul II, that consummate astronomer, in 1992 declared that divine revelation has been revised, and Earth is no longer at the center of the universe. Had he waited one more year for the return from space of the Kobe probe in 1993, the cosmic background explorer would reveal the Catholics were now wrong on both Luther and Copernicus, while the atheists kept on praying that God will never find them. Galileo. In the 100 years after Copernicus came Kepler and Galileo to develop the Copernican paradigm that we today call the scientific revolution. On this model, the Earth became an ordinary planet, and history books give the impression that the new model solved all the problems of astronomy. But to agree with the observations, Copernicus had to crucify Occam's razor and make planets follow, from Earth's perspective, a more complex system of epicycles than Ptolemy's model. As Professor Otto Neugebauer pointed out, the popular belief that Copernicus's heliocentric system constitutes a simplification of the Ptolemaic system is obviously wrong. The Copernican models themselves require about twice as many circles as the Ptolemaic models. ChatGPT states it does. From Earth's perspective, Ptolemy's geocentric model might seem simpler at first, but Copernicus's heliocentric model is mathematically more elegant and logical in the long run. End quote. When a machine has developed a preference for elegance over accuracy, we can safely conclude it has not escaped the bias of modern science. Not only was the Copernican model no simpler, its predictions were no more accurate either. Alfred North Whitehead, a British mathematician and philosopher, from his book Science and the Modern World, noted, The Copernican construction could not predict or describe so accurately as the Ptolemaic system. Scientific observation was definitely more favorable to the old than to the new. But science is not all observation. Copernicus rejected Ptolemy on aesthetic grounds and not because of any failure to account for the observed facts. Yet, when he arrived at his own conclusions, he took the position that at last the real truth had been found. Approximately 100 years later, Copernicus's idea was taken up enthusiastically by a professor of mathematics at the University of Venice. Galileo Galilei taught as a proven fact that the universe revolves around the sun. Galileo built a telescope and believed it to be the solution to the heliocentric controversy. He made many observations, one of which contradicted the old paradigm, as he noticed moons were orbiting Jupiter. This, of course, did not prove that Earth is orbiting the sun, but it did prove the divine revelation to be incomplete. If God has revealed himself to the Church, he should have mentioned the moons of Jupiter. Maybe the Church should have learned from this embarrassment not to claim what Scripture does not. Informed by historians of science, we tend to believe the telescope shows Earth's movement around the sun. But the telescope, like the human eye, cannot distinguish between relative and absolute motion. Seeing the moon rise with or without a telescope neither prove nor disprove Earth to be spinning. Likewise, it does not prove Earth to be moving around the sun every year. To measure absolute station or motion require a different tool. This tool would test c, the speed of light, from which the velocity of Earth, v, can be derived. But this tool would only be invented 250 years later. Galileo's theory of relativity was called Galilean invariance, an antecedent of Newton's first law. One can summarize Galileo's logic as follows. The Church believed all heavenly bodies orbit Earth. The telescope showed Jupiter's moons do not orbit Earth. Therefore, Earth orbits the Sun. If you fail to see the logic here, don't despair. There is none. Galileo did not prove the Earth to be moving around the Sun, but having proved that some bodies don't orbit Earth, broke the paradigm. Like discovering the tooth fairy does not exist, make one wonder about Santa Claus. Tycho Brahe was a contemporary of Galileo, whose model perfectly explained the moons of Jupiter. His was a hybrid model with all the planets orbiting the Sun and the Sun orbiting Earth. Brahe thus demonstrated that in fact Jupiter's moons, circling Jupiter, circling the Sun, circling the Earth, does not technically challenge the paradigm of their day. But by now Ptolemy was dead, 1,500 years, and his model of a geocentric universe was falling out of fashion. As Thomas Kuhn expressed it in The Structure of Scientific Revolutions, a new paradigm was born. Tycho Brahe was also born in 1546, 29 years after Martin Luther nailed his 95 propositions to the doors of the Castle Church in Wittenberg, Germany, starting the Reformation that gave impetus to the Renaissance. Brahe is credited as perhaps the most meticulous observer and record keeper of his day, and he believed the Earth to be at the center of the universe. He was distrusting of his protege Johannes Kepler, a heliocentrist and mathematician, 25 years his junior and 7 years younger than Galileo. Kepler was a Pythagorean of sorts, and if his belief system had merit, he may have been the reincarnation of Pythagoras, or Copernicus himself. Johannes Kepler was born into a Lutheran home that did not believe in the ancient sun god Helios of the Greeks or Ra of the Egyptians, but he seemed to have agreed with Pythagoras that the magnificence of the sun is godly. To Kepler, the sun was not just a physical body. Kepler knew Copernicus was right, just as Copernicus knew Pythagoras was right. Both of them knew by faith alone. They had no evidence, but Kepler believed he could prove his theory of relativity if he had access to Brahe's data. Fortunately for him, Brahe dropped dead at 54. Kepler superseded Brahe at age 30 and was appointed the new imperial mathematician, inheritor of Brahe's data and suspected of assisting in the demise of his mentor. This prompted exhumation of Brahe's body in both 1901, when it was confirmed he had been poisoned, and in 2010, when it was confirmed he was not poisoned, or he was not poisoned by Kepler, or something. It's amazing what dead bones can tell with application of enhanced interrogation techniques. On a personal note, I have been admonished to not judge a brother Christian as Kepler may have been, and implicating him as a sun worshipper. So let me concede, I do not know to what extent he did or failed to worship the sun. But fortunately, I don't have to. He confessed his belief in writing and left that impression among his peers. Kepler published Astronomia Nova, the new astronomy, in 1609, in which he referred to the sun as the image of God the Father. This is quite similar to Pythagoras, who had his God at the center of the universe, but differ from scripture that teaches man, and not the sun, was made in the image of God. Kepler was not quite a sun worshipper, and not quite not. If he was a Christian, he did not place much store by the advice of the Christian God, in passages such as the following: "And when you look up to the sky and see the sun, the moon, and the stars, do not be enticed into worshipping things the Lord your God has appointed to all the nations." Deuteronomy 4:19. Man was made in the image of God. The sun was made in the image of the greater light to rule the day, not to rule during the day, nor to rule mankind. For creation to be of service to God's people is a biblical principle. For people to honor impersonal objects is a transgression. The sun is our servant, not our God. It is accountable to its maker, but fortunately it does not have free will. Imagine if it had. Being wrong does not preclude anyone from being a Christian, just as being a Christian does not preclude us from being wrong. It is supposed to help, as Jesus said, "By their fruit you will recognize them." But let's say a Christian today decides that what God really wants is to reduce the population and preserve resources. We may debate whether he is a good man, but there is no debate as to his allegiance. He does exactly what the earth god Gaia expects from her worshippers. Does that preclude him from being a Christian? Perhaps not. Does that prevent him from following God's instructions to multiply and subdue earth? Most probably. Newton's third law states that reaction follows action, almost a paraphrase of the Apostle Paul. Whatever a man soweth shall he also reap. If Kepler intended to preserve God's impression of the universe, he failed. Of course, God may be mistaken, and Kepler may be right. We will soon see. The ancients' view of the universe was geocentric, with a stationary Earth and the sun, moon, and stars revolving around Earth. It was best described by Ptolemy in AD 150 and remained popular for 1,500 years. After Copernicus, Kepler, and Galileo popularized the heliocentric view. The new idea did not come from observational evidence. A telescope can convince an observer on an asteroid that he is at the center of the universe, but a telescope cannot determine absolute rest or movement. Therefore, it cannot reveal the center of the universe. What the telescope did was to demonstrate the equivalence between relativistic models. As long as we cannot measure absolute station or motion, any point of reference may be considered stationary. In fact, it is the most rational position to assume, even if one happens to be a Martian. We all are most concerned about ourselves, our family, our neighborhood, our country, our planet. To each of us, we are the center of our universe, and compelling evidence is required to convince us that some other person, family, country, or planet is more deserving of our concern. Considering the geometric equivalence of all the cosmic models, why would we conclude that the best perspective on Earth is for it to be an insignificant missing speck of dust? Hawking states that his choice of models follow from his humility. But are we really that humble? Is Hawkins? Are you? Why? Of course, we all have subjective preferences. Some wish to avoid being called a flat earther or wish to pretend an insight into the fiction spun by Einstein. It's better to be sophisticated on a missing speck of dust than contrarian on a special planet at the center of the universe. One benefit of the Copernican model is that it allows the ghost of Pythagoras to find his God, going to the light by the fire. But as we will see, the ghost may discover there is no God on Helios, and the heliocentric model is threatened mostly by scientists who keep trying to prove it. The next 300 years would be a search for evidence to prove what they already knew. But before the evidence was found came 1642, the year Isaac Newton was born and Galileo died. Chapter 8. Isaac Newton. The history of science can fairly be divided before Newton and after Newton. Astronomers up to Kepler compiled empirical records of what was observed and employed a form of pattern recognition to predict future events. They had no idea or proposed no theories as to why the heavens move as they do. Brilliant though they were, compared to Newton, they were spectators. Isaac Newton almost did not write down the Principia. He seemed to have had a habit of inventing amazing stuff and misfiled it somewhere. Stuff like calculus he developed in 1656. A debate heated up among astronomers about the work of Kepler, and Edmund Halley visited Newton in 1684 to get his opinion about ellipses and the inverse square law, to which Newton gave some offhand responses, claiming to have calculated it a long time ago, but being unable to find these calculations. Halley encouraged Newton to write it down again. Newton agreed and can be said to have over-delivered as he penned solutions to most of the questions of his time and provided answers for which many had no questions. The Principia contained the laws of motion that till this day is used to torture school children and help us know where to find useful stuff, like the moon. Unlike Einstein, he did not experiment exclusively in thought, but conducted various physical experiments, such as sending light through a prism, testing refraction and reflection, spinning buckets, and many others. But he also made theoretical discoveries like the Earth's equatorial bulge. He called his writing Mathematical Principles of Natural Philosophy, or the Principia for short. This started a controversy when Gottfried Leibniz realized Newton had used calculus in the Principia, a mathematical technique he believed he has invented, though it was sufficiently different to confirm they had both developed it separately. Newton was less interested in aesthetic solutions, seeking rather to understand what makes the heavens move. He suspected it had nothing to do with the ranks of gods and explained that what animates the universe is gravity, without ever explaining what gravity was. Having illustrated the working of gravity and invented a calculus to prove it, he made his theories and laws of motion useful in astronomy as in everyday life. But he struggled with a problem. If gravity affects all matter, why does the universe not collapse? Newton undoubtedly was aware of the geo-heliocentric debate and could have endeared himself by supporting the one over the other. But he understood the two-body problem following Kepler's work. Newton realized that if the universe had only one Earth and one moon, neither would be at the center. To solve the two-body problem, Newton pretended that Earth and Moon was one body with a common center of gravity. The same works for the Earth and the Sun. Both Earth and Sun would orbit the common center of gravity of the two bodies, which would not coincide with the center of either body. When considering a third body, say Jupiter, the combined center of gravity would move again and would keep changing as the relative position of the three bodies keep on changing. This is known as the three-body problem, or n-body problem, for it does not get any easier when more bodies are added. Even modern AI cannot solve the n-body problem that would produce a roaming center of gravity. Newton did not find it to be a useful answer, and unlike Galileo, he never pretended to have discovered the center of the universe. He was convinced it would be neither the sun or the moon. To remedy the difficulty of a roaming center of gravity, Newton considered a hypothesis that the universe may be infinite, as that may balance the forces to avoid the collapse of the universe. But in an infinite universe, every object will have an infinite amount of universe on either side. If infinite equals infinite, then Earth and Sun would both have the same amount of universe to either side, which is a definition of being at the center. But so would all the other bodies in the universe be also, or conversely, the center would be at every point of the infinite universe. The purpose of the infinite universe hypothesis was to explain how gravity would animate the universe without causing its collapse. Evidently, the hypothesis failed, as Newton confessed the difficulty in letters to Richard Bentley, a theologian. He realized that even an infinite universe would need divine intervention to prevent its collapse. Einstein tried to solve Newton's problem in 1915 by substituting the divine with a cosmological constant. He later confessed this to be the greatest mistake of his career. God may be eternal, but as Einstein discovered, he is not a constant. To determine absolute rest, whether on Mars or the Moon, remained the holy grail of astronomy. For without it, the heliocentric and geocentric models differ only in the chosen point of reference. If slightly more accurate or aesthetically pleasing, these models are identical. Ernst Mach said, "Obviously, it matters little if we think of the Earth as turning about on its axis or if we view it at rest while the fixed stars revolve around it. Geometrically, these are exactly the same." Fred Hoyle said, "We know the difference between a heliocentric theory and a geocentric theory is one of relative motion only, and that such a difference has no physical significance." Stephen Hawking said, "We have no evidence that the sun is at the center. We believe it because of humility." Because of the vast humility of scientists in general, and Hawkins in particular, most choose to go with teaching what they were taught by and about the great Galileo. But even scientists often attempt to avoid the dissonance from believing what is unproved. Copernicus so feared the church, he published his theory post-mortem. Galileo was placed under house arrest to shut him up, and today academics have no hope of advancement should they postulate theories or research fields in opposition to mainstream science. But even those with the best intentions will often stumble upon evidence that demands a verdict. Elementary, my dear Einstein. Chapter 9. A Suspicion of Bias. Thus far, I have aimed to demonstrate that the conclusions of science tend to give benefit of the considerable doubt to the ancient philosophies of Pythagoras. We have seen that the heliocentric model is in fact not the new astronomy, as Kepler claimed, but the reincarnation of a 2,200 years old idea. Theories that has not stood the test of time, of natural law, or scripture. Though geocentricity is hardly the core message of the Bible and should not be bickered about by Christians, it does sketch an idea of a caring God who made a special earth for a species in his image. He chose a special nation to seed his Messiah, more or less in the geographical center of the world. The Christian faith is centered on the Son of Man who came to seek and save the lost. It seemed unlikely a creator seeking the lost would situate them on a planet he cannot find. Contrast this with Carl Sagan's summary of Hawking's work, a universe with no edge in space, no beginning or end in time, and nothing for a creator to do. Such extraordinary claims require extraordinary evidence. Up to Isaac Newton, a skeptic of the Catholic views may have concluded reasonably that the Catholic Church has such an abundance of bad ideas, one may take the opposite view in most things and be quite close to the truth. Protestants conflicted with Catholic views on salvation, the papacy, and the authority of Scripture, but they also threw away baptism of babies, mainly because the Catholics does it. Scientists figured if the Church believed in a geocentric world, the heliocentric model has to be better. Thus far, the main want was evidence. Self-evident truth does not require proof, but between Copernicus and Galileo, the heliocentric theory has been hatched and groomed to take over the thinking of scientists and the modern world. The Renaissance was the hatchery, Copernicus the cock, Galileo the guardian, and Kepler ranged the roost. It was a happy time for 185 years in which no experimental evidence interfered with a brand new paradigm. The later period of the Renaissance was called the Enlightenment and was coincidentally punctuated by a rapid increase in the understanding of the properties of light. Though the heliocentric model never got Newton's blessing, neither did the geocentric theory. But Galileo had a fancy telescope from which everybody learned that one can see mountains and craters on the moon, phases of Venus, and moons around Jupiter. When its inventor claimed that he now knew the Earth to be orbiting the Sun, it is not irrational for most reasonably literate laymen to believe what Galileo preached. Though I was happy to discover that even today this worldview is far less prevalent than it is preached. To his credit, Galileo tried to measure the speed of light, but failed. A Danish physicist, Ole Romer, 66 years after Galileo, came close and measured the speed of light to be around 220,000 kilometers per second. 11 years later, Newton published his Principia, but gave no clear guidance as to the station or motion of Earth. Newton did many experiments with light, but so did Robert Hooke. As Newton proved the particle theory of light, Hooke proved the wave theory of light. Today we believe they were both correct, but it was the wave properties of light that soon led to discovery of polarization, interference, and a refractive index. These properties would lead science to the Holy Grail, a way of measuring absolute motion against the constant speed of light. In 1728, a British astronomer, Bradley, set up his telescope in the usual manner, with light entering at the center of the optical lens and exiting at the center of the ocular lens, to observe light from a star, Gamma Draconis. A few months later, he noticed that though the light was still entering at the center of the optical lens, it was exiting slightly off-center at the bottom of the telescope. He verified his setup and kept observing. The light kept drifting, but after 12 months it had returned to its original position. He noticed that the aberration of the light had formed an ellipse, all around the average position of where he expected the light should have been. The obvious conclusion would have been that he had observed a star moving in an ellipse. But Bradley now demonstrated an affliction of the mind we all struggle with. Like the eye cannot distinguish between relative and absolute motion, the mind struggled to distinguish between paradigm and paradogma. Dogma is in fact a paradigm of which we are unaware. A paradigm can shift with new information, but when it fails to adopt, it is called a paradogma. We all think in paradigm, a frame of reference, a worldview. It is shaped by our education and culture. Culture is derived from cult, that we associate with religion. A paradigm is extremely useful as it arranges our ideas in order so we don't have to rethink every aspect of life in every situation. It is like an operating system for the mind. A paradigm is also dangerous. If today, 5 years after the pandemic, we see a person in the USA wear a mask, we immediately assume he votes Democrat, believes in transgenderism and open borders. This leap generally improves the efficiency of our understanding, but it can also mean he is a doctor. When a patient ignores his advice because he wears a mask, the patient has contracted a paradogma and is now suffering from paradogmosis. It can lead to death and is extremely prevalent among religious people, cult leaders, and scientists. Bradley grew up within a heliocentric paradigm. We don't yet know if it's a paradogma, but we will see how it affects his interpretation of data. He had observed over the course of a year the elliptical movement of a star. Somehow he concluded that the star, which he saw with his own eyes to be in motion, is in fact stationary, and Earth, of which he has not observed or sensed any movement, has to be moving. This sounds like the logic of Galileo. The moons of Jupiter orbits Jupiter, therefore Earth orbits the Sun. Both these men seem to be afflicted with paradogmosis. Bradley believed he had stumbled upon the answer to an age-old question: how to prove that the Earth is in orbit. The Copernican theory requires Earth to be moving, but Earth's movement was not evident. Bradley realized what he must have observed was actually not what it seemed, but instead the observation was caused by Earth's orbit around the Sun. Bradley correctly called his observation the aberration of starlight because he observed a deviation from the expected location of a star. Perhaps the paradigm of his day inspired Bradley to think beyond the obvious conclusion. He offered an ad hoc theory, which means a special theory, based on an assumption. Informed by his paradigm, he assumed that is in an elliptical orbit at a velocity of around 107,000 kilometers per hour, perpendicular to the transit of light through the lens of his 6 feet long telescope. It would take a bit of time for the light to move through his telescope. During this time, the Earth would have moved in its orbit around the Sun. This movement caused the light to be dragged behind ever so slightly as it moves through his telescope. He thus demonstrated at last that Earth is in orbit around the Sun. For the next 49 years, science could breathe more easily. Their pet theory was confirmed. Copernicus was right. The scientific revolution was vindicated. They have found the evidence. I should introduce a working definition of what I frequently call science and the individuals who practice science. Let's define science as the popular or official theory, the party line, if you wish, while scientists are the individuals who experimentally expand knowledge of the subject matter. These individuals are often quite bothersome, as they are the ones with sufficient understanding of the details to notice where official science may be in error. Some of these individuals, with sufficient understanding of the details, realize that if Tycho Brahe's model is accurate, with all the planets orbiting the Sun, while the Sun orbits the Earth, Bradley would have made exactly the same observation, but with an entirely different explanation. The observed elliptical motion of some stars, called stellar aberration, would not be the cause of Earth being in orbit around the Sun, but by actual movement of the stars. To the layman, this seemed quite obvious. Imagine stopping at a crossing, noticing the train approaching. The obvious conclusion would be that the train is in motion and therefore I should remain stationary. To conclude that the train only appears to be moving and I only seem to be stationary may not lead to the optimal course of action. Yet that is exactly what Bradley concluded. He saw stars moving in ellipses and concluded Earth has to be in orbit. We can conclude that either he is correct and Earth is in orbit, or he is suffering from paradogmosis. The only way to know is to design another experiment to test the conclusions he claimed. As Carl Sagan would have it, extraordinary claims require extraordinary evidence. In 1767, Rogero Bošković proposed a method of obtaining the required evidence. He came to realize from various experiments done by different scientists that the speed of light is not always the same. Light moving through glass or vacuum or water move at different speeds. Of course, being gifted linguists, scientists rather named it the refractive index. Bošković must have been searching for a useful application of his knowledge when he realized differences in the refractive index may reveal which of Copernicus or Brahe's models is supported by Bradley's observation of stellar aberration. He proposed that an identical experiment be carried out, but the second telescope be filled with water. Due to the differences in the refractive index, the transit time of light through water is 50% slower than through air. So the sideways movement of Earth, which is believed to cause the aberration, will still cause the aberration, but 50% larger. This outcome will prove that apparent stellar aberration is in fact caused by the movement of Earth around the Sun, and Bradley would be right. If the ellipses remain the same size, however, it will demonstrate that the aberration is not caused by the dragging behind of light. It would mean that the apparent movement of the stars are caused by actual movement of the stars. It would also mean that the Earth is not in motion and has to be at the center of the universe. But Bradley was 65 years old at the time and still basking in the fame of having proved Earth's orbit. Most scientists were so confident that the Earth orbits the Sun that they thought proof unnecessary. In 1871, a British astronomer, George Biddle Airy, realized that someone ought to do Bošković's experiment after all. He filled a telescope with water and started observing. When consulting that bastion of truth, Wikipedia or ChatGTP, one will be informed that the purpose of Airy's experiment was to test the presence of an ether. In fact, the proper way of verifying the presence of the ether was done by various scientists we will soon discuss. Airy's experiment was asking a very specific question to test between two theories. If the Earth is moving at 107,000 kilometers per hour in its orbit around the Sun, then light transiting the second telescope would take 50% longer and be dragged along 50% further to make an ellipse 50% bigger. But if the stars are moving, no dragging of light would occur, and the ellipses would have exactly the same size from either telescope. Nobody proposed any objections as to why the test would not be valid. Remember, they had 39 years to ponder Bošković's proposal. Airy set up his telescope and started observing. As the year moved on, and the water-filled telescope traced its ellipse, Airy realized that the size of the ellipses are exactly the same. He has just disproved Earth's movement around the Sun. 200 years into the heliocentric paradigm, most every scientist had accepted the theory without a thread of evidence. But when an experiment was conducted, the gods at the center of the universe were nowhere to be found. Unfortunately, the results was not compatible with the scientific revolution. As Thomas Huxley characterized the problem, the great tragedy in science is the slaying of a beautiful hypothesis by an ugly fact. The scientific method should have required a revolt against the scientific revolution, back to a model supported by the experiment. Instead, Airy's experiment became known as Airy's failure. for observing movement of stars when movement of the Earth was required to enable orbiting the most magnificent god at the center of the universe. Instead, Airy's experiment became known as Airy's failure, for observing movement of stars when movement of the Earth was required. Copernicus offered no evidence of Earth's motion, but was believed. Airy proved by experiment that Earth is stationary, and was called a failure. The god of Pythagoras may not reside at the center of the universe, but he sure has the power of persuasion. Elementary, my dear Einstein. Chapter 10. A Tale of Two Theories. The establishment of a proper theory typically starts with observation of a pattern. Consistency of a pattern may prompt a hypothesis as to how this pattern occurs and predict the next thing that will happen. If in practice the next thing doesn't happen as predicted, the theory will have failed. If the outcome cannot be repeated by other observers, the theory will have failed. If a less convoluted explanation provides better predictions, the theory will have failed. The explanation with the least number of assumptions and variables has the best chance to survive. This is a scientific method. It leans on Occam's razor that predicts the simplest explanation is usually the correct one. There is another type of theory. It is derived from a Latin word ad hoc. It means special, or in this case. The best way to understand the purpose of an ad hoc theory is by analogy. A man returns home early and finds his wife scantily dressed in the kitchen with a neighbor in attendance, wearing only his jockstrap. The husband forms a theory in his mind that something evil is afoot. Now let's say the wife explained. She was drowning in the swimming pool and called for help. The neighbor jumped the wall, ripped off his clothes, and rescued her from peril. This is what we call an ad hoc theory. Of course, we actually call it, "Do you think I'm stupid?" But in science, it's called an ad hoc theory, or a special theory. It attempts to restore faith in the status quo, despite new evidence to discredit the initial understanding of a pattern, theory, or evidence. Depending on how much the husband wants to believe that he is happily married to a loving wife, he may place his faith in the ad hoc theory too. One prediction of the special theory is that he will never see the neighbor half-dressed in his kitchen again. As this is a very favorable outcome, he may adopt the ad hoc theory. Scientists are much like the husband. They make an observation and adopt their theory to fit the evidence. But the institution of science is more like the wife. It prefers holding on to the status quo. It will offer every fanciful explanation thinkable. It will attempt to convince the husband that drowning and getting rescued every afternoon is more plausible than suspecting her of conniving behind his back. In the case of Airy's experiment on the aberration of starlight, a conflict arose between the results of the scientific revolution and the results of the scientific method. The scientific revolution convinces us that the Earth orbits the Sun. The scientific method refused to support these claims. If Earth is stationary as showed by the evidence, it cannot be in orbit. What science needed was an ad hoc theory to explain away the evidence, because the alternative is philosophically impossible. Sherlock Holmes stated it thus: whenever the impossible has been eliminated, whatever remains, no matter how improbable, must be true. Scientists set out to find, however improbable, any explanation that will save the scientific revolution by disproving the results of Airy's experiment. It was not easy. For the next 24 years, the heliocentric model was like a whale in the desert, gasping for subsistence, having nothing to support it. It had received a mortal blow, dead as a doornail. But then a man came up with a solution to the problem. Hendrik Antoine Lorentz recalled work done by Augustin Jean Fresnel in 1818. Fresnel noticed movement of liquids form eddy currents, and eddies make visible shadows. indicating its optical effects. This can be seen in the bathroom when hot water is added. Lorentz enlisted Fresnel's observation to concoct an ad hoc theory to save the dead idea of Copernicus. He reasoned that since we know there is an ether, and we assume Earth is moving, then Earth dragging through the vacuum of space containing the ether may cause a turbulence, a drift in the ether that has optical effects. It may make the ellipse observed by George Biddle Airy bigger or smaller, or larger in winter or smaller in summer, or just generally chaotic, as is the nature of turbulence. But Lorentz further imagined it just so happened that the chaotic turbulence of the ether could be blamed for hiding the 50% increase in the size of the ellipse that Airy failed to observe. By this masterful logic, we can believe the experiment showed Earth to be in orbit without showing Earth to be in orbit. The collection of assumptions is quite remarkable. Nobody has ever shown any similarity between properties of water and properties of a vacuum. Yet we assume these are sufficiently similar to form the foundation of an ad hoc theory acceptable to science. Anybody tempted to criticize this ad hoc theory was faced with a simple question. If not blaming ether drift for the bad news, what would you blame? How do you explain away the evidence? Ether drift became the official explanation of science. At the time, nobody had any doubt in the existence of the ether, and the ether was absolutely necessary to obfuscate the obvious. But note the circular reasoning here. We assume Earth is moving. We assume movement of Earth caused turbulence of the ether. We assume ether drift negates the observation. Having abolished Airy's proof of a stationary Earth, we may again proceed to orbit. The scientific revolution was saved by the imagination of Hendrik Antoon Lorentz. The man returning from work every day, finding his wife and a neighbor in the kitchen, has adopted the special theory of relations. Sherlock Holmes was still flowing from the pen of Sir Arthur Conan Doyle at the time of this atrocious application of his principle. Had Sir Arthur deployed such stupendous improbabilities in his fiction, nobody would have bought his books. But when science spins these incredulities, we hang on the lips of gods. By continuing the pretense that science was conducted, the dead whale of a theory was placed on life support. It never swam again and would soon die, but that did not stop science from flogging its corpse for some time to come. During this time, no books had to be unwritten, no PhDs were cancelled, and the most magnificent of all the gods sat perched on his fiery stool at the center of the universe. By rejecting Airy's experiment, science was again stuck with theories of relativity. Geometrically identical models, some aligning better to Scripture, some to Pythagoras. In the meantime, James Clerk Maxwell had brought together the known facts on all the theories, including observations on electricity and magnetism, and formulated what became known as Maxwell's equations. He demonstrated that light is an electromagnetic phenomenon. Radiation, such as light, consists of energy, which constantly switches between electric and magnetic waves, reacting with the ether. His theory made predictions that could be tested to support or falsify it. One of these predictions was the existence and usefulness of radio waves and X-rays. These were soon discovered to confirm his theory. Maxwell anticipated light to become a useful instrument for measuring absolute station or motion. Science was inching forward, approaching the holy grail of light, for the properties of light would soon disclose a very inconvenient truth. Chapter 11. Interfering with Interference. Thomas Young had discovered the interference of light in 1801. Interference can be displayed as fringes of light exiting a double slit in a solid object. Through experimentation with transparent liquid in pipes, Hippolyte Fizeau 50 years later, noticed that interference fringes would shift to display altered patterns of interference when viewed from upstream or downstream. This observation led to modern-day development of laser Doppler velocimetry and other flow sensors that can tell the direction and velocity of flow in a pipeline. Albert Michelson was a naval officer and physics instructor. Michelson was basking in the success he had in 1880 for measuring the speed of light. Presently, he was studying Maxwell's predictions and pondering Airy's failure to demonstrate Earth's orbit in 1871. He was also contemplating the observations of Hippolyte Fizeau. Michelson realized the implication of ether drag, blamed for Airy's failure, may imply that the ether share properties with fluids. If Fizeau can detect relative movement between light in water, he should be able to measure relative motion of light as it propagates through the ether. Throughout history, every model of motion was relative to other bodies in motion at unknown speeds. But having discovered the fixed speed of light is the first step in finding absolute station, something at rest, something that has absolutely no movement. Michelson realized light moving at a constant speed provides for the first time a frame of reference to measure absolute station. He knew he had to build a new instrument. The instrument Pythagoras did not have, the bugs on the water wheel did not know that they did not have, and Isaac Newton did not have. He decided to build an interferometer. We may reasonably wonder how the interferometer would measure absolute station from light that is in motion. Let's consider the following analogy. A boy on a horse is chasing a train, hoping to discover how fast his horse can run. The boy takes 2 minutes to gain 10 boxcars at 20 meters each. He calculates his horse was running 6 kilometers per hour faster than the train. Knowing the constant speed of the train to be 50 kilometers per hour, he can now calculate the speed of his horse to be 6 kilometers per hour plus 50 kilometers per hour. He now knows his horse was running at 56 kilometers per hour. Now, let's say light is running at a constant speed. A scientist on a mountain is chasing the light, hoping to discover how fast his mountain is moving. The scientists assume the planet his mountain sits on is moving at 30 kilometers per second in its orbit around the sun. But how can this be measured? How can he confirm his assumption? He cannot count boxcars. Michelson enlisted a colleague, Edward Morley. They constructed an instrument and called it an interferometer, able to make 2 measurements at once. It could display the constant speed of light in the form of interference fringes, but it could do this measurement from 2 directions, perpendicular to each other. The reason that one arm will display interference fringes of light parallel to Earth's movement, representing the constant speed of light, c. This is comparable to the constant speed of the train illustrated above, while the other would indicate different fringes resembling the combined movement of Earth, v, with the speed of light, c. This is comparable to the speed at which the horse is running. They did their experiment. They found no difference. C plus V equals C. A 7th grade pupil can solve this equation. V equals 0. The Earth is standing still. The outcome of this experiment rocked the stationary world. At least it rocked the scientific world. The bugs on the hub of the water wheel, using this instrument, would discover at last one is circling the hub while the other is at the center. If Earth is not in motion, as demonstrated by Michelson and Morley, it follows that Earth is at the center of the universe. For to orbit anything, like the bug on the water wheel, it would have to be in motion. The scientific revolution spun in its grave as the whale in the desert gasped its last breath. There is no Helios at the center of the universe. There is only man, made in the image of God our Father. Chapter 12. When a dog gets a train. Science had been searching for means of measuring absolute rest, like a dog has been searching a train to catch. But having caught it, they did not like the taste, they did not like the answers it gave, and most of all, they did not like the implication. The mediocrity principle had been demolished. Order in the universe has been restored, and they hated it. The universe at last had a center. The center is stationary, and smack in the center is Earth. Evidently, God agreed with the measurements of Michelson and Morley. It is said of God, He established the earth upon its foundations, so that it will not move forever and ever. Psalm 104, verse 5. Despite the guidance of Scripture, Michelson and Morley's experiment was the third attempt to prove that Earth will move forever and ever. Of course, I'm not counting Galileo, for he did not actually measure Earth's motion. He inferred it from Copernicus, who inferred it from Pythagoras, who inferred it from knowing that the sun is the most magnificent of all the gods at the center of the universe. The first experimental attempt was made by James Bradley in 1728. Bradley convinced the eager scientific community that he at last had found evidence for their faith by showing Earth's orbit. For the first time, and for 143 years after Bradley, science had some observation that may support the heliocentric theory. But Rogero Bošković showed that Bradley's observation was inconclusive. The second attempt was made by George Biddle Airy. He tried in 1871, only to prove Bradley had been wrong all the time. Then came Michelson and Morley, and they unintentionally rolled back the scientific revolution. They did this by disproving the heliocentric theory of the universe. It caused much mourning and gnashing of teeth. Science went through the normal stages of grief, starting with denial. The first to deny the findings of Michelson and Morley was Morley and Michelson. Believing Earth to be in orbit around the Sun, they refused to give up. They did not wait for other scientists to provide ad hoc theories as to why their measurements gave the inconvenient results. They invented their own ad hocs. They imagined that perhaps Earth's rotation may have been opposite to Earth's orbit, and so these may have cancelled each other. They repeated their experiment 12 hours later. Earth was still standing still. They reasoned that perhaps Chicago was not the ideal location for observing Earth's motion, so they tried it in Berlin. They tried it on the tops of mountains all seasons of the year, day and night. Their double-barrel interferometer showed no fringe shift. They confirmed that He established the earth upon its foundations so that it will not move forever and ever. The findings of the Michelson and Morley experiment may have been the only thing God and Einstein agreed upon. But unlike God, Einstein was 8 years old at the time, with his entire life ahead of him to explain away, if not the results, then the way in which the physical universe has conspired to give them the wrong result. For unlike God, Einstein knew that the Earth is in orbit around the Sun. The results were simple. Velocity of Earth equals 0. As Earth is stationary, it cannot orbit the Sun. The equation for velocity is displacement over time. If some way could be found to change the values of either displacement or time, the value of 0 would be derived from unknowns. Therefore, v would again become unknown, which is much better than 0. If it can be demonstrated that 0 is not actually 0, Earth can be imagined to be in orbit again. The man who came up with the solution was George Francis Fitzgerald. To correct the undesirable value of Earth's zero velocity, Fitzgerald proposed to fix the dimensions of the interferometer in such a way that the distance through the one barrel would be different from the distance through the other barrel. If one of the barrels had secretly contracted during their measurements, unnoticed by Michelson and Morley, it would explain why the interferometer showed no fringe shift. Fitzgerald explained the elemental matter of which the interferometer is constructed, the grains of the metal, would sense the direction of Earth's movement and contract only the barrel pointing in the direction of movement, while the other remained in its original dimension. When turned 90 degrees, the alternate barrel would contract while the first barrel returned to its original dimensions. Fitzgerald invented length contraction. A change in the length of the interferometer will change the apparent displacement of light moving inside. Considering the equation for Earth's velocity equal displacement over time, and having invented a way to alternate the dimensions of the interferometer's barrels, the new equation is velocity equal unknown displacement over time. If displacement is an unknown, then so will v become unknown, despite measuring 0 on the interferometer. We now have to accept that 0 equals unknown. It took mathematicians centuries to agree on the value of 0, and it took Fitzgerald but a moment to show that 0 is not 0 anymore. If Earth's velocity is 0 and not 0, then we can imagine Earth to be in orbit again. The dog has lost the train. One has to believe an instrument with features designed to observe its own velocity failed to do so. Yet it had secret properties not designed to observe anything, but it had. Based on its secret sensing of its own movement, it was compelled to alter its own dimensions, just enough as to hide the observation it was designed to reveal. This theory is ideal for people snorting opium, or who live in a jar, who has never held a piece of metal, or someone born in a library. Working with metals for a living, I know of various aspects like strain and temperature that make metals expand and contract. But no metallurgical textbook explains the contraction of metal due to Earth's orbit. Yet it's a foundation of theoretical science. It predicts that space can be altered without changing dimensions. It is a pillar of the scientific revolution. To the reasonably literate layman, it is utter nonsense. There was one more way of fixing 0. As we have seen earlier, Earth's velocity v equals Earth's displacement over time. Pondering the implications of Fitzgerald's contraction, Hendrik Lorentz realized one implication is that a spinning wheel would have components moving both parallel and perpendicular to the ether, just like the interferometer, causing the circumference to contract while the diameter remained the same. Pi would have to be reinvented. Archimedes would turn in his grave. Lorentz came up with a better solution for changing 0. What if, instead of changing space, time can be altered? Note that Lorentz did not specify more or less time, for time can be measured, but he imagined a way of making the same time last longer. This will have the same effect of eliminating the fringe shift inside the interferometer. But Lorentz was also a linguist, and he came up with a fancy name. He called it time dilation. Of course, Lorentz did not identify the agent informing time when to dilate, just as a secret agent telling metal when to contract remains unknown. But by application of faith in the God of Pythagoras, at second glance, flexible time and space starts to appear quite reasonable. Or as Hawking stated it, we believe it because of humility. Chapter 13, Guardian of the Principle. Einstein started at age 16 to do thought experiments, imagining himself to be riding on a light wave while looking in a mirror. As he would be moving at the speed of light, he asked himself the question, what reflection would there be from the mirror? Presently he was considering Fitzgerald's faith in metals contracting and Lorentz's idea of time dilating. Being a past master at imagining reality, it is no wonder that he was able to make use of both Fitzgerald and Lorentz's ideas. To Einstein, both of these seem obvious, not because it resembles our daily experience, but because it supported an ad hoc theory he had been hatching. As the Pope is the guardian of the magisterium, Einstein found his calling as the guardian of the scientific revolution. Both pretend submission to higher law, but both improvise when necessary. As the Pope dispensed canon law, Einstein became a prolific author of scientific principles. Principles are not exposed to verification by new evidence, as had been the sad lot of the heliocentric theory when it has thrice been proven wrong. Principles, on the other hand, don't require evidence, they are evidence. So instead of risking more ridicule by experimental findings, the scientific revolution is now wrapped around the Copernican Principle. It is a method of starting with the answer and then finding evidence to support it. The Copernican Principle states that humans are not privileged observers of the universe. We do not occupy any special position in the universe. Conversely, if our position is neither special nor privileged, then the earth on which we reside cannot be privileged by a central location in the cosmos. As we have learned, the Latin phrase ad hoc means for this situation or special. Einstein published his special theory of relativity in 1905, not based on any evidence other than the principles of Einstein. Principle 1. The laws of physics are the same in all inertial frames of reference. An inertial frame of reference means a location that seemed to be stationary. Like sitting at a dinner table or sitting in an aircraft, these may both seem stationary. When pouring coffee in mid-flight, we would follow the same method than pouring coffee at the dinner table. We seem to have found evidence that the plane is not in motion, even though we know that it is. Conversely, while experiments show Earth to be stationary, like the dinner table, we can keep believing that it is in motion like the aircraft, even though we know that it is not. When objectively measuring airspeed, we find the aircraft to be in motion, while Michelson and Morley found the dinner table to be at rest. Why then do we have to believe the dinner table is moving at 30 kilometers per second around the sun? Because that is what Einstein's principles demands. How did Einstein prove this? He did not. What is the measured speed of Earth? 0. Why then don't Einstein stick to the evidence? Because if Earth is stationary, it has to be at the center of the universe. Principle 2. The speed of light is independent from the observer's motion. This means that testing an interferometer from a stationary or orbiting planet will give the same results. Whether the observer is in motion or stationary, the interferometer will always show the planet to be stationary. We therefore have a choice. We can take the same evidence to support either movement or station of Earth. Such scientific poetry is remarkable for its elegance. Of course, we don't know what the Michelson-Morley results would be on another planet or even on the moon, for among more than 100 experiments done on the moon during 5 landings between 1969 and 1972, the Michelson-Morley experiment was strangely excluded. One may wonder why perhaps the most remarkable scientific experiment was not repeated on the moon. The answer is simple. Einstein already predicted the outcome of such an experiment 64 years before the moon landing. You of little faith, what is the point in testing it? 8 years after publication of Einstein's special theory of relativity, George Sachnak built an interferometer and mounted it on a turntable. By turning the table, he hoped to simulate the movement of Earth, and by holding it, he expected to repeat the zero measurement of Michelson and Morley. Of course, if Einstein was right, he would see no fringe shift, whether his table is stationary or rotating, and he can use the table as an ornament. As everybody expected, including Einstein, Sachnak's experiment showed no fringe shift on a stationary table. But to Einstein's horror, when the table was rotated, a fringe shift occurred. If Einstein's first principle was correct, and all inertial frames of reference are equal, then observation of a fringe shift would have been impossible. If Einstein's second principle is correct, and the speed of light appears identical in any direction, observation of fringe shifts would have been impossible. 2 years later, Einstein published his general theory of relativity. Although he never conceded his mistake or reinstated the ether that he abolished, he did the next best thing. He renamed the ether to the fabric of space-time, also called the Sagnac effect. Of course, it made no difference to how light propagates, and his theories are mutually exclusive, but the special theory is the only pillar of the scientific revolution. Like the theory of evolution, it is fact-free, but compared to the alternative, it is quite elegant. Clearly, NASA knew not to repeat the Michelson and Morley experiment on the moon. Why would they precipitate the greatest scientific embarrassment since Copernicus? But between 2013 and 2024, China, India, and Japan all sent craft to the moon. These craft use ring laser gyroscopes for navigation. The ring laser gyroscope is based on Sagnac's turntable interferometer. Just as Sagnac's experiment predicted, the ring laser gyros provide perfect detection of phase shifts. Spacecraft on the moon and rovers navigating on Mars are real-time proof that Einstein's special theory of relativity is utter fiction. As the heliocentric theory died from a lack of evidence, the special theory of relativity was proven to be fiction. Of course, you can still believe whatever you want, but you now have been deprived of the deception that you were compelled by evidence. If you have a PhD, you may have no choice other than contracting a paradogmosis of the mind. For without the special theory of relativity, there is no scientific revolution. Chapter 14. Einstein's More Excellent Way. Once practical experimentations proved unreliable in supporting the scientific revolution, Einstein realized not all experiments show what they are supposed to. Some questions arose. Are all experimental findings true? Are we to accept them just because they are true? Einstein coveted a better method of arriving at truth, and he would teach the entire world his more excellent way. We cannot ask him, but we can examine his record. Copernicus adopted Pythagoras but offered no experimental proof. Einstein endorsed him. Galileo taught Earth to be in orbit but offered no experimental proof. Einstein endorsed him. Bradley claimed Earth to be in orbit. He offered no experimental proof. Einstein endorsed him. Yet, when George Airy tested Bradley's claim to be incorrect, Einstein rejected his experimental findings. Michelson and Morley measured Earth's velocity to be zero. Einstein rejected his experimental findings. Sagnac disproved the equivalence of all observers. Einstein rejected his experimental findings. Einstein showed a clear preference for thought experiments over empirical science. Like most mortals, he preferred to ponder rather than to act, to feel rather than to think, dreaming rather than design. But most mortals don't claim to have solved the secrets of the universe. Einstein was not called an impractical dreamer, which he was. He was called a theoretical physicist, which is an oxymoron. We already had a term for people who imagined the nature of nature. We called them natural philosophers, people like Aristotle, René Descartes, Francis Bacon. These ancients did excellent work with what limited observations they were able to make. Einstein's conclusions were made despite the observations available to him from experimentation. Calling him a natural philosopher would be an insult to the ancients. So, what should Einstein be called? We could call him a dreamer, for that is literally how he did his first famous experiment at age 16. Calling him a theoretical physicist would imply that real physicists conduct random experiments devoid of theory. They just throw chemicals together and see what blows up. In fact, the denominator theoretical applied to Einstein does not add to his CV. It is a fashionable, high-sounding confession of his being removed from reality. Einstein became captain of a league of theoretical scientists after him, including Schrödinger, Heisenberg, and Richard Feynman. They all found inspiration from studying creation while denying its creator. Unrestrained by scripture, natural law, or experimental verification, Einstein arrived at his most popular explanation in 1905, ironically called his Annus Mirabilis, or miracle year, so named by atheists who, like Einstein, did not believe in miracles. Einstein's theory apply at the speed of light where mortals seldom wander. His fame is based on allowing science to perpetuate the fiction of Earth's orbit around the Sun, supporting a scientific revolution that in itself has no physical significance. But to the philosopher it offers fuel to theories of mediocrity, of an Earth missing in the vastness of space. To the reasonably literate layman, the invention of the wheelbarrow has added more usefulness and truth to our everyday lives. We are told that even though Einstein's theory of special relativity seemed ludicrous at the time, we are to credit it in retrospect because it has subsequently been applied in correcting time dilation from GPS satellites. This may or may not be true. There are alternate explanations producing equal results, but in the Church of Science no such dogma is allowed. The layman is expected to simply accept what scientists preach. When Maxwell's equation predicted X-rays and radio waves, it may have seemed equally ludicrous. Imagine unheard voices traveling to another country without a telegraph wire. But 20 years later, Heinrich Hertz built the first radio. Did Einstein credit Maxwell's theory in retrospect? No, he simply declared that there is no ether. Maxwell's theory was based on an absolute reference provided by the ether. Einstein's theory is incompatible with anything absolute. We have to credit Einstein retroactively, but he did not credit Maxwell in the same manner, even though Maxwell gave us electricity, microwave dinners, and Wi-Fi. Conversely, are we to believe that radio waves would never have been invented if not predicated by Maxwell? Are we to believe a nuclear bomb will not have been built without Einstein's letter to Roosevelt? Einstein had virtually nothing to do with the Manhattan Project, except for promoting it, and then spending the latter parts of his life trying to undo the invention he championed. Yet he is credited for nuclear electricity, as if nobody would have thought of it without Earth orbiting the Sun. Whatever the reason for its happening, Einstein, like the scientific revolution, is not subject to critical review. They have both been reincarnated. The revolution is now a principle, and Einstein is a saint, or rather a messiah. Like Jesus saved undeserving sinners, Einstein saved an undeserving worldview. He forgave all the evidence against it. He started a church for scientism, unrestricted by facts, experiment, or empirical observation. Had Einstein been alive today, he would be impressed by the way in which science had followed his commandments, so that presently we have no absolute frame of reference, no absolute truth, no respect for empirical science. We can sound intelligent while disputing the existence of a Y chromosome, the benefits of CO2, or the application of the scientific method to medicine and vaccines. Had Darwin been alive today, he would immediately jump off a cliff. For observing how Einstein's mediocrity has become gospel, how excellence is demonized, how incompetence is heralded, he thought survival of the fittest bring progress, but his definition of the fit was unclear, and his idea of progress was undirected. Presently, the least meritocratic is invading the West, who is searching high and low for ways to insult ourselves and demonize the skin color of our children, while doping on the confusion of Heisenberg. Having failed to explain the origin of the universe, we are told multiple universes are more probable. Why? To make the game of chance seem more plausible. The layman may think a multiplication of improbabilities make the outcome less reasonable. But from Einstein we have learned not to let common sense stand in the way of a necessary fiction. Having failed to explain the origin of life, we are told to believe it rained on the rocks, the rain turned to soup, the soup came alive, and here we are. The layman may think a single example of soup turning to life would go a long way in persuading us all. But from Darwin and Einstein, we have learned not to let a lack of evidence stand in the way of a necessary fiction. As the Catholic Church pretended to rule on behalf of God through their Pope, science now pretend to rule on behalf of truth through their saints like Hawkins, Dawkins, and Harris. But no matter what any of these men say, it can never be more ridiculous than their father Einstein. The Reformation of the Catholic Church did not ruin Christianity, it saved the gospel. It is high time for a reformation of the Church of Science. It is as necessary as the reformation of Christianity had been, not because science is devoid of truth, but because the only truth allowed is that sanctioned by the likes of their popes, first of which is Albert Einstein. Should we ever have to answer to our Creator why we credited the likes of Einstein over such reasonable observations we can make every day, what would we say? Would it be sufficient to quote Richard Feynman because he had a PhD, or Richard Dawkins because he was a professor, or Einstein because he was a messiah? Concluding that Scripture lacks some details on the moons of Jupiter may be a valid criticism, but our greatest difficulty is not in believing what Scripture fails to say. Our challenge is to accept what Scripture do say. In what way is it unreasonable that creation had a creator? It does follow logically, but the main objection is the implication. As the pot belongs to the potter, the created belongs to the creator. Some pots rather fracture than be useful to the potter. Some people deny their everlasting soul rather than presenting the image of their creator.